Hello everyone, hope you are doing well. In this video, we are going to discuss about empirical formula. First, we need to understand what empirical formula is at the first place. So we define empirical formula as a simple whole number ratio of actual molecular formula. So the actual molecular formula is never going to change. We are just simplifying it. It's more or less theoretical concept, but we can relate it to the mole concept, we can relate it to a number of things, and there are multiple steps that we need to follow in order to reach to the empirical formula, in order to derive the empirical formula. And if the data is given uh, based on molecular mass, we can calculate the molecular formula also. So empirical formula is a simple whole number ratio of actual molecular formula. We have a relationship of empirical formula and the molecular formula. So EF stand for empirical formula into some common factor that is equal to molecular formula. So MF is molecular formula and EF stands for empirical formula. Now N over here, if you remember from the previous lectures, I have discussed N, small n specifically, has multiple meanings in chemistry. So N is equal to, we define as a common factor. So let's take an example of C6H6. This is benzene. I'm not introducing the IUPAC name of this as of now. That we'll be discussing in the organic chemistry basics. So C6H6, we can see the subscript over here indicates 6 number. So what if I simplify it to CH? Now CH doesn't have a name over here. It's a empirical formula of benzene, at least in this case. It can be empirical formula of many things. So benzene in this case at least. Let's assume. Right? So if you can see 6 over here is the common factor. So we know empirical formula is CH into common factor, that is 6. So this is our empirical formula into common factor, that is equal to molecular formula. So if you multiply this will become C6H6. This is the molecular formula. Now if we compare the masses, we'll calculate the masses. Then also we can calculate the common factor. For example, if we know CH and C6H6, so it's a very simple multiplication that we're doing over here. So for benzene, C6H6, this will be 12 into 6 plus 1 into 6. So this will be equal to 78. CH is 12 plus 1, 13. So 13 into common factor. I'm doing it just to introduce that we can calculate common factor by dividing empirical formula to molecular formula. So molecular formula is molecular formula mass. This is also we write empirical formula mass into common factor, that is equal to molecular formula mass. So molecular formula mass is 78. N will be equal to 78 divided by 13. This is again coming to be 6. So this is one way. Still I haven't introduced the steps. We'll do it in a couple of minutes. Then one more relationship we need to remember that will be quite useful in different questions. So twice of vapor density. Obviously we are talking about a gas. That is equal to molecular mass of that gas. So how can we define vapor density? So we can define it as density of a particular gas or vapor relative to that of hydrogen at the same pressure and temperature. So usually vapor density definition is not that important. If it's a subjective paper, they can make us objective question also, like they can ask the above is the definition of vapor density, or they can give you multiple choice questions defining vapor density in the four options, and one of them is correct. So you have to choose that. They can even make an objective question out of it. But what we have to remember over here is this formula: twice of vapor density, that is equal to molecular mass. Now moving ahead, let's do a question in a hydrocarbon. Now what's a hydrocarbon? It's a compound of carbon and hydrogen. Percentage of carbon is equal to 80%, hydrogen is 20%. Now even in this question, if they have written hydrocarbon, possibly there are only two elements, carbon and hydrogen. Now if they have given only carbon as 80%, if they have not mentioned hydrogen as 20%, you can subtract it from 100. Total percentage of the compound will be 100, as carbon is 80. 100 minus 80 will be 20. So sometimes they try to give questions where multiple elements are there: carbon, hydrogen, sometimes oxygen, sometimes nitrogen. They might give for the three elements percentage, but the fourth one they might not give you. So what you need to do in that case, sum it up all, subtract it from 100, because the total percentage is always going to be 100. Is given. Calculate the empirical formula. So how do we start this? First, we are going to write our elements. We are going to write their percentage. So element we have only two, carbon and hydrogen. 80% is carbon, hydrogen is 20%. So the next step that we are going to do is write the masses. Carbon is 12, or you can say gram atomic mass also we can write. 12, hydrogen is 1. Now next part that we have to calculate is the moles. Now remember one thing. We said number of moles, we wrote like this: number of moles is equal to given mass divided by molar mass, given number divided by Avogadro constant, given volume divided by 22.4 liter. So when we see these identities in the numerator, so it defines that number of moles can be directly proportional to mass, number of moles can be directly proportional to number, and number of moles is definitely directly proportional to volume. And this is very famously called as Avogadro law, that we'll discuss in the gaseous state. So the point over here is that number of moles that we are calculating based on this percentage. Now percentages can be taken as the grams, like 80% means 80 gram in total 100 gram. It can be taken based on the concentrations. Now you might have studied about the concentration of solution specifically, but we can relate this percentage, we can take it as 80% That means 80 gram in total 100 gram, 20 gram in 100 gram, like that. So 80 gram divided by 12, then we have 20 divided by 1. So we can take 80. This is equal to 6.66. So up to 2 decimals we can take. We don't have to extend it to the third decimal. 20 divided by 1 is going to be just 20. Now the next step that we have to calculate is the least value. Like out of this 6.66 and 20, which is the lower number? The lower number is our 6.66. So again, we are going to divide it. So this, instead of writing least value, we can calculate the simple ratio. So we know the least one is 6.66 divided by 6.66, again 20 divided by 6.66. This is 1 equal to, this is approximately equal to 3. So exactly if we want to calculate 20 divided by 6.66, this is equal to 3.003. So 3.003 we can take it as roughly equal to 3 only. We don't have to take the decimals. So now these are the simple ratios. So this number 1 indicate carbon is 1 in our empirical formula. Hydrogen is how many atoms? 3. So why I've written this? If you see, the number of moles are directly proportional to the number of atoms. So if we simplify this value, this is indicating us the number of atoms in the empirical formula by dividing it with the least value. So first we calculate the moles. Moles, if we don't calculate, then definitely we can't go to this step. So there are multiple steps to calculate the empirical formula. This is how we need to do in the tabular form. First write the elements, their percentage. Sometimes they will write in the grams. If it's given in the gram, best you calculate the moles, number of moles over here, divided by the gram atomic mass, and you will get these values. You always, in this step of number of moles, you always have to take the least value out of all. If it's carbon, hydrogen, if it's sulfur, oxygen, nitrogen, any element, you have to compare all the values and you have to take one as a least. Now the least values can be same in different elements. That's okay. That's not a problem. So 6.66 is a least value, 20 is a bigger value. So which one will I take? I will take this. Again divided by the same values. For carbon, it is coming to be 1. And for 20, like for this hydrogen, it's coming to be approximately 3. So we have calculated empirical formula. So that was our question. But what if I extend this question? So we can calculate the empirical formula mass of CH3, 12 plus 1 into 3. This is equal to 15. So now if we twist this question, if we say given molecular mass that is equal to 30. So if I change this question, so I added a new information. They asked only calculate the empirical formula. Given molecular mass is 30. Now if they're asking after this, like molecular mass is given, calculate the molecular formula, then what we're going to do? So our empirical formula is, I'll go empirical formula, we calculated this. Empirical formula is 15. Molecular mass given over here is 30. So we will do that. Empirical formula mass into common factor, that is equal to molecular formula mass. We have an empirical formula mass 15 into common factor, molecular formula mass is 30. It's given in the question. So N will be equal to 30 divided by 15. This is 2. So now we are going to write empirical formula CH3 into the common factor. that is equal to molecular formula C2H6. Now this is our molecular formula. This is called as ethane. It's a hydrocarbon, it's a gas. C2H6 is our answer. So this is how you need to do it. So next, if we take another question, now that's a simple one. The empirical formula of a compound is CH2O and its molecular weight is 120. Calculate the molecular formula of the compound. So this whole question can be converted into MCQs also, just to confuse you more. But if you read this question properly, you can just get into just one answer. Now we know empirical formula of a compound is given, that is CH2O, and its molecular weight, that means they have given molecular formula mass, that is 120. So we can calculate empirical formula mass. We know mass of carbon is 12, hydrogen is 1 into 2 plus oxygen is 16. So this will be 30. So this is empirical formula mass that we calculated. 20, yeah, that's correct. So molecular formula mass is given. So we'll do again the same empirical formula mass into common factor, that is equal to molecular formula mass. Empirical formula mass, we have our answer as 30. Common factor we need to know, we need to calculate. Molecular formula mass, it's given in the question, that is 120. So it will be 4. So our empirical formula is CH2O into 4 will give you C4H8O4. So now this compound can be anything. It's having 4 oxygen atoms. So we are not going into depth of what compound name it is over here, because it's written in the molecular form. It's not given in the condensed formula or the structural formula, anything. So we can't depict what it is. But this C4H8O4 is the answer over here. So I hope you understood this question. So this was all about empirical formula. So I hope you have understood the question and you can do these similar questions in the long run. It's a very simple concept, mathematically based, and it's very easy to calculate once you know the steps. So thank you for learning with me. Hope to see you in the next video.